So welcome to this session. This session, we are going to do an example on projectile. So the question reads, a ball is thrown horizontally with speed 20 meters per second from the top of a building, which is 30 meters high. So there are two questions to answer. First is to find the time the ball takes to reach the ground. And then number two, to find the distance between the bottom of the building and the point where the ball strikes the ground. So when you meet such questions, it's always good manners to write or to draw a sketch to represent the information given in the question. And then from the sketch, you will be able to get the answer without any problem. So the ball is thrown horizontally. So these are some of the key things in the question. With a speed of 20 meters per second. And then it is from a top of a building, which is 30 meters high. So from that information, we can have the sketch. So assume this is a building. This is a building. And then this is the ground. So assume this where we have the distance of 30 meters. So the ball is thrown, when you throw a ball horizontally from this point, then this will be the trajectory of motion. Roughly this is how the object or the ball will move. And we have been told that at this point, the horizontal velocity is 20 meters per second. So that's what we have. So if we call this point O, call this point A, then we should be now in a position to reduce the problem into solvable form. Now, the first one is to find the time the ball takes to reach the ground. So the time the ball reaches point A. So we're interested in finding the time taken for the ball to reach point A. So as usual, we start by resolving the velocity both in the horizontal and the vertical direction. So resolving, the velocity of projection horizontally and vertically we have. So for horizontal, we can show by this. So this just means that you are resolving horizontally. So UX, so we have already been told that the velocity is moving, the object is, or the ball is projected with a speed of 20 meters horizontally. So therefore UX just be 20. And because that motion is purely horizontal, then there's no vertical velocity. So therefore that means that resolving vertically, and because I'm showing this arrow going down because the object is going down, UY will be 0. meters per second. Now we choose which direction to be positive to be able now to answer the part given the question. So the distance to find the time the ball takes to reach the ground. So I want us to assume that we are taking motion towards the ground, or the downward motion to be positive, so that the acceleration will just be the same as the gravitational acceleration. So we say, remember now solving A, taking downward direction as positive, so taking downward direction as positive, let's see what we have. So we have uy is 0, and then displacement, or sy, is 30 because this ball is being thrown downwards from a building at a height of 30. So the distance is 30. So just call it sy. And then we have acceleration is the same as g, the same as 9.8. Now positive because gravitational acts are vertically downwards. That's why this will be now having positive sign, because we have taken downward direction to be positive. And then time is what we don't know. Now, a formula connecting acceleration, displacement, and initial velocity is S equals to ut plus a half at squared. And now, in our case, we replace this one by sy equals to uy t plus a half. Now, where there's a, we put g, and then t squared. Now, put in the values we have. Sy, we put 30. Uy, we put 0 times t plus a half. G is always 9.8 times t squared. Now, this equation will be now 30 equals to 4.9 t squared. And that one means t squared is 30 over 4.9, which implies t, time is scalar, so positive square root of 30 over 4.9. Now 30 divide 4.9, square root of the answer. 30 divided 4.9, root answer is 2.47435829 seconds. So therefore, that is the time of flight. So therefore, the time the ball takes to reach the ground is approximately 2.474 seconds to nearest four significant figures. And then part 2, we have to calculate the distance between the bottom of the building and the point where the ball strikes the ground. So from our labeling, if we call this one point P, so we're interested in finding the distance from P to A. And then distance, so B, distance is always given by speed times time. Speed times time. And because we are interested in finding the distance PA, which is horizontal, so horizontal distance PA will simply be given by UX times time of flight, time we take to reach point A. From our resolving of the velocity components, UX is 20. So this will be given by 20 times 2.474, and this will give us 49.8716593. So remember, I've taken this one as the original value of this t. So roughly the horizontal distance is 49.49 meters. So that's how we solve that problem. So that the distance from the bottom of the building to where the ball hits the ground. Thank you.